In this video, what I am going to discuss about is shortcuts on 1 on 2 functions, means types of functions and also binary operations. Let us start with first shortcuts. In this case, first one is if number of A is equal to M and number of set B is equal to N. So then the number of functions, from A tends to B is equal to n to the power of m. So using this formula, we have to find out the number of functions from A to B in this case. When means what in this case? Number of A is given and number of B is also given. So using this formula, so take one example. If n of A is equal to, in this case, 3 and n of B is equal to 2, then the number of functions from A tends to B is what in this case? N to the power of m. In this case, n of B is equal to what? N. This is n. So this is m. So in this case, using the formula n to the power of m, nothing but in this case 2 to the power of 3 is equal to 8. So number of functions from A to B in this case 8. If n of A is equal to 3 and n of B is equal to 2. So what is the formula? This is n to the power of m. Very important formula we can use. So next, move on to the shortcut second. If n of A is equal to m, set, and n of B is equal to n. So then number of injective function, nothing but 1 function in this case, then the number of 1 are injective function. So 1 functions in this case, two types are there in this case, depends upon m and n value. So then the number of 1 functions, nothing but injective functions, is equal to the npm. If here in this case m is less than or equal to n case. So npm defined when m is less than or equal to n. So if m is greater than n, so number of injective function becomes 0. It is not defined. If m is greater than n, npm is not defined, it is equal to the 0. So using this shortcut, we have to identify the number of 1 function or injective function. So take one example. In this case, first one. So if n of A is equal to, in this case, m is equal to, we take 3 and n of B is what? N. In this case, we take 4. So then the number of 1 functions, nothing but injective functions, then the number of 1 functions is equal to, in this case, npm, because in this case n is greater than, here in this case n is greater than or equal to m, or m is less than or equal to n case. So we can use npm formula. So n is equal to what? 4 P3. 4P3 nothing but 4 factorial. So 4 factorial in this case 4, 3 and 2 into 1. It becomes 4 3 is 12, 12 2 is 24. So 24 1 functions are obtained if number of A is equal to M 3 and number of B is equal to N 4. In this case, if N of A is equal to M and N of B is equal to N, then the number of 1 functions from A tends to B. So A tends to B. Here also number of 1 functions A tends to B is NPM. So in this case M is less than or equal to 4. So we can use NPM formula. So now let us move on to the another example. In this case, if N of A is equal to M is equal to 4 and N of B is equal to N is equal to 3, so then the number of 1 functions from A tends to B is equal to 0, because here in this case M is greater than N. So if M is greater than N, number of 1 function becomes what? 0. Directly you can write 0, because in this case M is equal to 4 greater than or equal to N equal to 3. So you can use the formula M is greater than N if number of 1 function becomes 0. So these are the shortcut methods. 2. Next we take injective, nothing but in this case injective over. So next we take onto function, means surjective functions. So next move on to the surjective functions. So take down. So now let us move on to the shortcut number 3. This belongs to the number of surjective function, nothing but what? Onto functions. So now let us see the method. If number of A is equal to M and number of A is equal to M and number of B, in this case number of B nothing but what? In this case N of B. N of B is equal to N, then the number of onto functions, number of onto nothing but surjective number of onto functions from A tends to B is summation of R varies 1 to N minus 1 to the power of N minus R NCR into R to the power of M. So this is the shortcut method. This is the formula once again. This is, take one example. So if N of A is equal to M nothing but 1 and N of B is equal to N, here in this case we can use 2 in this case. Next find the number of onto functions from A tends to B is, so in this case summation is what? Is equal to summation of R varies 1 to N minus 1 to the power of N minus R NCR into R to the power of M. So here in this case R varies 1 to N nothing but N is 2. Put R is equal to 1 and then put R is equal to 2. Here summation is there. First put R is equal to 1 and next plus put R is equal to 2 and M is equal to 1. So here put r is equal to 1, minus 1, and n is equal to 2, minus 1, n 2, c r 1 to the power of m 1 plus next r is equal to 2, minus 1 to the power of 2 minus 2 n 2 c 2 r is also 2 to the power of m 1. So now simplify this. 2 power minus 1 to the power of 2 minus 1, 2 minus 1 1 minus 1, 2c1 2, 1 to the power of 1 minus 2 plus. So here cancel each other, minus 1 to the power of 0 1, 2c2 1, 2 power 1 2, 2 1s are 2, plus 2 minus 2 cancel each other, it becomes 0, correct in this case. So number of onto functions, if n of a is m nothing but 1, n of b is n nothing but 2, then the number of onto functions from a tends to b is 0, of course, because so here in this case set A contains only one element, it may be x. Is set B contains two elements, so nothing but y1 y2. Onto function means what? Every element in the codomain have pre-image in domain. So here in this case y1 have pre-image nothing but x, y2 onto function means what? Every element in the codomain have pre-image in domain, y2 is also pre-image x. So now it is not a function because x has two image. So function of course it is not a function. So number of onto function becomes 0. So now one more condition. If n of a is equal to m, okay, so m is greater than or equal to 2 and n of b must and should be equal to 2. So in this type of problem, then the number of onto functions from a tends to b is 2 power m minus 2. Directly we can write. This formula is obtained by once again this. So here in this case restriction is there. N of a must and should be greater than or equal to 2 and n of b exactly equal to 2. Then the number of onto functions from a tends to b is directly we can find out 2 to the power of m minus 2. So this problem can also be solved by using this formula, but very shortcut method in this case, but restriction is there. So this formula can apply for any problems, but this is apply for only restricted part. N of b must and should be 2 exactly equal to 2 and n of a greater than or equal to 2. So take one example in this case. If n of a is equal to m, in this case m we take 3 is greater than 2 and n of b is equal to 2, then the number of onto functions from a to b, a tends to b is here in this case 2 power m minus 2. M means what? 3. 2 power 3 minus 2. So 2 power 3 minus 2 nothing but what? In this case 2 power 3 8 minus 2 6. So number of onto functions from a tends to b, if n of a contains 3 elements and n of b contains 2 elements, is 2 power 3 minus 2 is equal to 6. So now let us move on to the next shortcut. So bijective 1 1 over and onto is also over. 1 1 means injective, onto means surjective. So two jective are there. So if satisfies both jective, that is called a bijective function. Bijective function means what? If it satisfies both 1 1 and onto. So find the number of bijective functions in this case. If n of a contains m and n of b contains number n, then the number of bijective functions means 1 1 onto functions from a tends to b is in this case m factorial or n factorial if m is equal to n, and in any another case it becomes 0 if m is not equal to n. So using this formula we have to identify the number of bijective functions. Take one example. So if n of a contains, in this case and n of b both are equal to 4, then the number of first one in this case, then the number of bijective functions from a tends to b is, in this case, n of a equal to n of b, hence you can use the formula m factorial or n factorial. So is what? M factorial, nothing but 4 factorial in this case. 4 factorial is equal to what? So 4 into 3 into 2 into 1 is equal to 24. So 24 bijective functions are there in this case if n of a and n of b both are contains 4 elements. So next we take if n of a is equal to 4 and n of b is equal to 3, then the number of bijective functions from a tends to b is, in this case, 0, because here in this case 4 is not equal to 3 and m is not equal to 3. It means m is not equal to n. So if m is not equal to n case, number of bijective function is what? 0. We can use this formula directly. We can write number of bijective functions of a tends to b is 0, because here in this case 4 is not equal to 3. So take now let us move on to the shortcut number 6. So here in this case it depends on 1 1 and onto functions. So how can you find out it is 1 1? Easily we can find out by using derivative, application of derivative, in this case derivative method. So in this case in the application of derivative, already well known about strictly increasing function and strictly decreasing function. Strictly increasing function and strictly decreasing functions are always 1 1 functions. Using this concept we have to write down the shortcut in this case. So if f of x be f from x tends to y be a function defined by a function f from be a function, let we can take in this case, let f from x tends to y be a function defined by f of x is equal to y is 1 1 when if and only if, both forward and backward in this case, if and only if f dash of x greater than 0 or f dash of x less than 0. It means strictly increasing or strictly decreasing function. So any strictly increasing and decreasing functions always 1 1. So take one example in this case. we know that in this case exponential and log functions. So here first one, f from real positive, in this case or any number, r tends to r positive, be a function. This is a function, is function defined by f of x is equal to e power x is 1 1, because using this condition directly we can write here it is 1 1, because f dash of x, in this case e power x always strictly greater than 0. So hence we can use this condition, this is 1 1. Similarly log f from r positive tends to r is a function defined by f of x is equal to log x is also 1 1, using same condition. So is also 1 1 because differentiate using the differentiation rule. In this case find the differentiation, f dash of x is 1 by x. Here in this case 1 by x is not equal to 0, input value all are positive real numbers, hence positive real numbers. In this case 1 by positive real numbers, it becomes positive, it is not equal to 0 and not defined case, so strictly greater than 0. So hence increasing function, hence it is we can call this 1 1. Now let us move on to the shortcut number 7. This belongs to the onto. So in this case same dialog, let f from x tends to y be a function defined by f of x is equal to y is onto function is 1 1, nothing but here in this case onto 1 1 over onto if and only if range of f is equal to, here in this case codomain y, domain x, codomain y. So if range is equal to codomain, then the function is onto function. If onto functions, then range is equal to codomain. So both forward and backward. Using this condition, so take one for example. So this is here a function f from natural number tends to natural number defined by f of n is equal to n by 2 and n plus 1 by 2. So in this case n by 2 we can use if n is even number input. If n is odd number, we can use odd number. We can use n plus 1 divided by 2. So is onto function. So identify it is onto function by using this condition, range of f is equal to codomain. So in this case first we have to find out the range. So input value natural number, output value either n by 2 or n plus 1 by 2. So range of f in this case, because range of f is equal to, so if n is equal to 1 nothing but what, input value natural number, 1 odd, using the formula 1 plus 1 2 by 2 1. If n is equal to 2, using this function 2 by 2 once again 1. If n is equal to 3 plus 1 by 2 3 plus 1 4 by 2, it becomes 2. Next n is equal to 4, again 2. n is equal to 5, using this condition 5 plus 1 by 2, nothing but 6 by 2, 3. So natural numbers are obtained. So it is equal to what? N. N here in this case codomain. So n codomain, this is codomain. So if range is equal to codomain, hence we can say that f is in this case onto. So okay. So now let us move on to the number of binary operations. 8th shortcut. So the number of binary operations on the non-empty set A contains n number of elements. N elements is directly you can write n to the power of n into n, or n to the power of n square. So take one example in this case. The number of binary operations on the set A contains 2 elements. Is, so here n is equal to 3, this is n2, sorry. Here n is equal to 2 means what? 2 power 2 into 2 is equal to what? 2 power 2 2 is 4. 2 power 4, here in this case 16, 2 2 is 4, 2 is 6, here 2 2 is 4, 4 2 is 8, 8 2 is 16 in this case. So number of binary operations on the set contains 2 elements is 2 to the power of 2 into 2, 2 to the power of 4 is equal to 16. So now let us move on to the shortcut number 9. Number of commutative operations. The number of commutative operations on the set, on the non-empty set A contains n elements is n to the power of n into, in this case is n to the power of n into n plus 1 divided by 2. So using this formula we have to find out the number of commutative operations. So let us be take in this case example. Same example, in the above example, n of A is equal to what? 2. So directly you can write the number of commutative operation. The number of commutative operation is equal to, here n is 2, 2 power 2 into 2 plus 1 divided by 2. So here 2 2 get cancelled, 2 power 2 plus 1 3, 2 power 3 is equal to 8. So directly find out the number of commutative operation by using this shortcut, and number of binary operation also. So take down.